In this section, we are going to talk about Cisco switch types. Cisco designs Catalyst switches for campus networks and Nexus switches for data center. In the context of our CCNP course, Catalyst switches will be mostly discussed. We have access layer switches, distribution layer switches, and core switches. For example, 2960X is an access layer switch and 6800 is a core switch of Cisco. Let's take a look to the layer 2 and layer 3 switches. Layer 2 devices can make just switching, while layer 3 can make switching and routing. Layer 2 switches send packet based on the destination MAC addresses in the frame. When switching is done in store and forward mode, the frame is checked for errors and passed on. Some models of the switches with most Nexus switches prefer to read only layer 2 information and change frame information based on skipping CRC checking. This bypass operation called cut-through switching. And cut-through switching reduces the delay of frame forwarding since the frame is not stored before it's forwarded to another port. Most Catalyst switches work on the store and forward mode. Let's see how we can create the MAC address table on a switch now. The MAC address table is empty first, as you can see that there's no MAC address or port entry. If PC1 wants to forward the packet to PC2, that's PC1 and that's PC2, switch flutes it out of all ports and adds the PC1 MAC address to MAC address table. That's the MAC address of the PC1, as you can see. In the second step, PC2 sends a unicast reply to PC1 and switch adds to PC2's MAC address to MAC address table 2. As you can see that's the MAC address of the PC2, and PC2 is connected to third port of our switch. After this process, if PC1 wants to send data to PC2, frame is forwarded directly in that direction. In the end, switch learns all of MAC addresses connected to all of its ports and establishes a full MAC address table. After this step, if PC1 wants to communicate with, for example, PC5, the packet is just sent from port 1 to port 8. Layer 2 switching is based on MAC address table, as we talked before. The layer 2 forwarding table, also referred to as the MAC address table, contains MAC address and destination port information about where the frame should be forwarded. If the destination MAC address is not found in the table, the frame is flooded to all ports in the same VLAN. And we have multi-layer switches, as you know. Multi-layer switches perform not only layer 2 switching, but also frame forwarding with layer 3 and 4 information. These switches combine the functions of a switch and router. Network devices contain at least 3 planes of operation, and they are management, control, and forwarding planes. And let's start with the management plane first. Management plane is responsible for network management operations such as SSH access and SNMP. And the control plane is responsible for the protocols and routing decisions, and the forwarding plane is responsible for the actual switching and routing of the packets. The control plane also programs the forwarding plane about how to route packets as well. Multi-layer switches have separate control and forwarding planes for high performance, and they can also use multiple forwarding planes at the same time. Cisco IS-based routers use one of three methods to forward packets, and they are process switching, fast switching, and CEF, which is Cisco Express forwarding. Process switching is the slowest form of transmission because the processor makes forwarding by software. Fast switching is a faster method by which the first packet in a flow is routed and rewritten by a route processor using software, and each subsequent packet is then handled by the hardware. The CEF, which is Cisco Express forwarding method, uses hardware routing tables for the most common traffic flows with only a few exceptions. If you are using CEF, forwarding processes are often separated from other tasks. Route caching is also known as streaming or request-based switching too. Route caching defines a layer 3 route cache created within hardware functions when a switch traffic flow occurs. Since there is no cache for the new stream in the route caching, the first packet in the stream is switched in the software by the processor. And for catalyst switch, fast switching is referred as the route caching and CEF is referred as the topology-based switching. The information in the topology-based switching routing table is used to populate the route cache independently of traffic flow. This generated route cache is called FIP, and the FIP creation tool is the CEF, Cisco Express forwarding.